Hi there, welcome back to this channel. In this video, we are going to be resolving a circuit, the resistance, the equivalent resistance of a given circuit. So we're going to be finding that. Now, how do we find the equivalent resistance of this circuit? So we have a circuit which begins from this junction and of course ends here. So it's going to be connected to a power source at the end of the day, but we just want to find the equivalent resistance of these entire resistances that have been given here. All right, now the first thing to do is this. You obviously cannot start from here, is that okay? So the first thing you want to do is to locate junctions. Now, how do we find junctions? So here is the first junction here. Now you see the wire or conductor branches out around here. So this point is going to be a junction. Now, so where the wire branches out, where the conductor branches out, is going to be a junction. So this is a junction. Our next junction, by the time you go on like this guy bends. So this is a kink, not a junction. A kink or a bend is not a junction. So this is a bend, another bend here. Then you see here, this wire here branches out here. So this is going to be a junction. Then if we continue further, as we go here, you're going to see that there is another junction here. And of course, here, this junction continues here until this junction, all right? So basically, at the end of the day, we have 1, 2, 3, 4, 5 junctions there, okay? Now, any set of resistance that any set of resistance that is within a junction, they are in series. Any set of resistance that is within a junction, they are in series. But set of resistance that are separated by junctions, they are going to be in parallel. Let me explain what that means. They are going to be in parallel, okay? So if you look here, this guy and this guy, this is a junction and this is a junction. The only resistance within that junction is this guy. But if you look at this junction, this second junction and the third junction, if you go like this, you are going to find two resistors rather, connected, or two resistors that are within that junction. So those two are going to be in series. Now, if you consider this guy also, this junction to this junction, you have only one resistor there. From this junction to this junction, you have only one resistor here. Then this junction to this junction, one resistor there. This junction to this junction, one resistor. Okay? So if they are bounded by a junction, if they are within the same junction, that's going to be series arrangement. And if they are in parallel, they are separated by junctions, they are going to be in parallel. Now, how do you resolve in series? Remember that in series, the equivalent resistance is going to be R1 plus R2 plus R3 up to any number of resistance that you're given. Now, this is in series. This is series. But in parallel, 1 over R will be equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus ... up to any number of resistance that you are given, or number of resistor you are given. So, in this case, how do we now resolve? Now, beginning from here, you're going to see that these two guys are within the same junction. So they are what? In series. So if they are in series, then you have this. R will be equal to R1, which is 3, plus R2, which is 2. So that becomes what? 5 ohms. Okay? Now, if you are giving this in theoretical exams where you need to write, now, you might have to show what kind of what the junction, the circuit would have become. As in this circuit now, you have resolved it. It would have reduced in size, kind of. Is that okay? Because you have brought these two junctions, these two resistances together. You found their equivalent. Is that okay? So, but since it's not, I'm assuming it's not theory now, so we're just going to solve to get an answer. Is that okay? So these two give us what? Gives us what? 5 ohms. Now, if you look at the 5 ohms resistor and the 6 ohm resistor, they are going to be separated by a junction. There is a junction here and a junction here. So because they are separated within, they are separated by this junction, then, I mean, what that means is that if we start at this junction here, what we have here is going to be our 5 ohms resistor now, and what we have here is going to be our 6 ohms resistor. So this is parallel arrangement. So if this is parallel, then you go by 1 over R to be equal to 1 over R1 plus 1 over R2. So, and if that is the case, then 1 over R will be equal to 1 over 5 plus 1 over 6. And if that's the case, then you have, the LCM of this is going to be what? 30. Or basically say 5 in 30 is 6, 6 in 1, 6 times 1, 6 plus 5 in this, 5 plus times 1 is equal to 5. So you have 6 plus 5 is going to be 11 over 30. So there you have 1 over R is equal to 11 over 30. Therefore, R will be equal to 30 over 11 because this is 1 over R, which is the inverse of R. So if it's the inverse of R, then what is R? R will be the inverse of this, or reciprocal of this, which will be what? 30 over 11. Let me bring that up here. So we have resolved these two circuits into 30 over 11. Okay? So what that means is this. That here our circuit has become, so I'm just going to wipe this place off, wipe it off, and then we'll have 30 over 11 here. So this place has become 30 over 11 ohms. So this is our new resistor, our new circuit, and the equivalent resistance of all of those ones that were on top here initially. Okay, so now that we have this, you are going to see that this is no longer a junction because we have resolved everything here. So this is just continuous with the 7 ohm resistor. So if that is the case, then we say that this guy and this guy are in series. And if they are in series, therefore we're going to have R in that case is going to be 30 over 11 plus 7. Is that okay? So this becomes, you know, this is 2 number 8 over 11 plus 7. This becomes 9 number 8 over 11 ohms. So this is going to be the equivalent resistance for this part here. For this part. Okay? Now you now notice that this part and this part and this part, they are separated by junctions, which means they'll be in what? They'll be in parallel. So what do we have? We have 1 over R will be equal to that guy. The equivalent of that guy is this. That is 1 over this. So let's convert this. This will become this by this. It's going to be 99. 99 plus 8. That is 107. 107 over 11. So 1 over R is going to be 1 over this, which will be 11 over 107. 11 over 107. Then plus 1 over this. That is 1 over 12. Then plus 1 over 5. 1 over 5. Okay, so let's resolve this first. That's going to be 1 over R equal to 11 over 107 plus LCM of this and this is 60. So we'll have 12 plus 60, that's 17. Here, on top, you are just going to 12 in this 5, 5 times 1, 5, plus 5 in this 12. 12 times 1, 12. So you have 1 over r you have 1 over r will be equal to 11 over 107 plus 17 over 60. All right, so if that's the case, I'm going to employ the calculator in solving this. So 11 divided by 107 is going to give us 1 over r will be equal to 0.103 plus 17 divided by 60. 17 divided by 60, that's going to be 0.283. 0.283. So 1 over r becomes, this plus this is going to be 0.386. Alright, so that this is the inverse, so that r becomes 1 over this. R becomes 1 over 0.386. And if that's the case, R becomes 2.59. R becomes 2.59 or 2.6, approximately 2.6. So R is approximately 2.6. And that's going to be our, okay, we have no result, so we have only resolved this part. So what we have left, having gotten 2.6 for this portion of the circuit here, now we're going to resolve it with this. So our circuit has now become something like this, with this one being the 9 ohm resistor and this part being the 2.6 ohm resistor. So what is this? This is in series, therefore our equivalent resistance here, R, will be equal to what? that will be 9 plus 2.6, and that's going to be what? 11.6 ohms. So that's how to resolve that circuit. Do what to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. Thank you as you do so, and God bless you.